So, in order to get our project to replicate the same things we are doing on my overview section, let's start working on the last part we had here for the project. And I'm going to go ahead and start it by building the things we are going to need. So let's minimize here, and let's actually now start to build the systems we want. So a new folder here that's going to be quite important is a new one we're going to build, and we're going to call it as RTS scripts, because they do not fall in the category of systems, because they do not have a node, and they don't fall also in the category of RTS object, because they are not going to exist inside of the project, and they don't belong on the object section, but they are related to the RTS, and I don't want to have a single folder called on scripts. That's why we are calling RTS scripts. And they are going to hold the logic for our next two folders, which are going to be Obj Actions. And also a new folder is going to be our Obj Data. So this, mind you, is following this principle here. We have actions for objects and we have attributes for them. That is why we have these two folders here. So now let me go ahead and create those scripts here. So for Obj Actions, let's create a script that's going to be our constants holder. So it's going to hold constants for our object scripts, for the Obj Actions. So let's create a new script and let's paste here the code that's going to do that. So this is only going to hold enums for the action names itself. We are going to have at the moment an action for move and an action to be selectable. So let me see if I can rearrange this to always be visible, because now this is where the part is going to get a little more complicated. So let's try to make this simple. So we have constants for Obj Actions. Let's also add another for Obj Data. So let's add here a new script to be the constants of our Obj Data. Let's open that script and let's paste here the code. So just holding enums for to be used by the data object. So this is going to be the attributes itself of what they do. And here you can place comments and also define if you want like integer stuff, just like a normal enum. Next, we're going to need managers for both of these things, because they have a way of handling these systems that we need to enforce. So we're going to need a new script here, and I am calling them like main manager, so we have a distinction between them. So we're going to need the main manager for RTS Obj Actions, and we are also going to need a one to handle the handling of Obj Data. So we have a main manager for our Obj Data as well. So for the handling of our Obj Data, there's a bunch of code here. So if you are trying to copy all of this code just by seeing it, it might be a daunting task, but you don't need to. It actually is fairly simple, and all you need to know is that this is the code that does it. So let me briefly explain what Obj Data main manager is. So this is going to be the script that's going to handle the manipulation of Obj Data. Obj Data being the attributes of what a object has. So here all we have is a function to debug the information from a object, which is this one. Here we have information that's going to return the data from the dictionary. And one question you might have is why I need a function for that and I just can't type this. In order for you to make this code easier to work with, you don't have to remember that you are accessing Obj Data. You also don't have to mistype Obj Data inside of your code, because you're using the API from the Obj Data main manager. You're going to just pass, I want the data dictionary from this object. So this ensures your code will never reference another thing, because the code for all units is going to use is from object.objectData. This allows you to enforce a type. So whenever your unit needs to retrieve data from the object, we're going to use this. So this returns the Obj Data as a dictionary, as specified in the function. Here it returns a data value from the dictionary. So we pass the object, which is going to hold the data, and the key we want to retrieve. So all they do is going to access the Obj Data and retrieve a key. Now this key is going to be as a data key, and this is just integers. That's why this function here under the data main manager expects a key as an integer. we do not want to pass here a random number, but rather the key itself as an integer, because this is going to be a num. So whenever we reference an object data, we're going to be accessing the object data constants to retrieve an attribute. This ensures us we have a readable name to it rather than have just random ones and say that this is HP instead. This is much more readable and is also functionally works the same as have integers. So that is why we use the key as integers for this one. Here we're going to check if our dictionary of object data has a given data key. We're going to ask for an object if it has that key as an integer, and it's going to return that object data as a dictionary because we want to be able to check if it has a specific key. So this is all this function does. Next we have the set data value. Now, the functionality of this function is pretty simple. All it does is going to set an object data with a given key to a new data value. And this part of the functions ensures we are passing the same type. So by you checking the type of a given var, so this you can use on the global scope of Gdscript, it's going to return the internal type of the variable. So it's going to return you in integer values if it's a new value, a boolean, an integer float, or the string. We can also check if they are any of these values. So that is the way we do it. So if we have a different value, then we're going to do that. We're going to push an error and say that we have a different value. Now, my globals function, so let's also update that. I believe we have an outer load here for globals, which does not have that function yet. So let's add the function that's going to return us the type of a variable as a string, so we can actually print it in the debug code. So sadly in Godot, you cannot retrieve the type of a variable as a string, so I have to make this super dirty way of returning a string based on the type of the variable. So we match if it's a type new, so we are basically doing if this property is of a given type. So it actually did not load. Here we go. We are checking for every single type of a variable, then we are returning a string value. So the way that this function can be used as, for instance, here on our, and I don't know why it's not returning, so I believe it was data manager. Whenever set a new value for a key, we want to check if it is the same type, because if it's not, we're going to print that as an error. So we be able to get some debug information that we are trying to set an object data with a different type that was expected. That's everything that is doing. So this is what this global thing here is doing. So if I save, I should be able to click on this, and it's going to return a string based on the type of the variable. So yeah, that is all it does. And if none of these matches, we're going to return an unknown type. So yeah, that is what this function does, but you can also enforce anything you want here, any kind of logic you want. This is what I'm doing. The next one is a add data value. So this is because there might be some specific situations inside of our object data that we want to add value. So we want an array type. So our object data could be as simple as one of the we have discussed here. So let me place here. You're going to see that we mainly have information like this is going to be an integer type for, so let's say that hit points is going to be a num, and we have here an integer assigned to it. But what if you wanted to have a something like such as these properties down here? So we have attack against what armor classes. So this is going to be an integer, but this is going to be an array type because we want to have multiple types of information. So in order for us to have this functionality of adding information like an appending dictionary, appending inside of an array, we need to check if we have first this variable here. So that is what this part of the code is doing. I have a data value action here to be doing it, and this is going to add value to the data as an array. So just like we have explained here, we want to add information, not set the information. So the way that it works is that if we have that data key first, before we even have set it, all we want to do is we want that expected variant to be an array. That is the first thing. We want to grab that value, and if the expected data is an array, then we can start adding values. If not, if we don't even have the data key, we simply set the value to a new array. So if we are checking the array and we find that we already have that data value, we're going to return and do nothing because the data is already present. So we are only adding new values inside of the array, because the logic is, if you want to add information inside of an array, what you do when there are conflicts of that array and stuff like that. So this is stuff you can also think about on yourself, how you want to handle it. We're going to be using this for data types that need to be added and not set it. We only set the value if we have already that data key. So if we do not have that information, I'm going to simply append it as a new value, thus adding that value to our data function. So that is all the code for our data main manager, and we only have a single reference here, which is used for the object constants. And I only believe we are using it to debug information. We're not even using to set it, because in reality, we don't need to access the object data. This is just code that's going to be used. So that is all for our main object data manager. Now let's handle our action manager here. So our object actions manager is going to handle and stores the actions themselves. We do not yet have the actions, but we are going to build them from here. But here we need to reference them inside of the script, hence why we have here an action script list, which is going to use enums as the reference point to scripts, which we are going to preload here. So we can simply say that our objects can use these scripts, and it's going to have a API function that's going to initialize the actions by passing the actions inside of our actions array, which is going to be the object. So let's say that a unit, which is the caller, is going to initialize its actions. That is how we're going to do it, and we're going to simply call this function. So we do not exactly know if this script is going to have this function. We are thus expecting it. That is why this can be a little hard for you to debug or work inside of your code, because you do not know if these functions actually belong to the scripts. But the arrows should make sure that works. For instance, here we don't have the actions themselves. So we have constants and we have our managers for object actions and object data. Now let's add the actions themselves. So let's create a new script here, which is going to be our action move. So this is what's going to allow our objects to move. And this is the code that does it. So all this is a transplanted code from our RTS object unit back to here. So for instance, let me just show you what we have new here. We have a function that is allow us to call it whenever physics stick. We're going to use that inside of the unit itself. And we have a function that allows us to initialize this action. So important to remember that for every action of ours here to work, so in order for a unit to repair buildings, it needs to have repair amount, repair types, attributes that we're going to work inside of that action to allow a unit to work on repairing buildings. So in order for that, every action needs to have an initialize action. And as you can see here, for our movable action, we only need to set some types. We need to create a object path variable, an object path goal, and an object current path index. Stuff we already have inside of our RTS unit, but here it's declared through variables. So let's go to our RTS unit, which is not this one. It is our basic units. And here you can see that we have path, current path index, and we also have eliminated the usage of these. So here we have movement speed, path, and current path index. In our action of movable object, we are going to need only object path, the goal, and the current index. And here we can specify the type for this object data, which is going to be a vector tree array. So we are basically rebuilding the same structure for our basic units, but now inside of our object data dictionary. So this is what this function do. The function called on physics stick is basically a transplanted version of our unit. Whenever on its physics process it has move a path, we're going to request to follow the path. The action move itself is going to first say that we want to grab our object path from the object data. So you access the script data manager and asked for its data value. So we want to grab the object path as a vector 3 array, which is basically the type of the object we want to expect. So if we go to our basic units here, our path is expected as a vector 3 array. So in order for the action to check for its size, so if we actually have a path, we are going to start following it. And this is going to be a function we're going to call for our action inside of the basic player, our basic unit, just as it's calling here directly the follow path method. The follow path method was this function here, and I can actually copy it and go to my Object Actions follow. And here we have the function itself. So let me just unzoom. Yeah, I don't know if I'm going to be able to show it. So if I just copy over it, there are some new lines here, main for code clarity, but basically is almost the same thing. For the path follow, we have some changes here. First, we need the path. So the path is not declared inside of the script. We need to grab it from the object caller. So we are asking for the data manager to get the data value from the caller, which is the object path. Here we're using an aliases. So aliases is just to shorten the code path, because otherwise we would need this bit of code here. So you're going to see how this gets very long to do inside of every single one of them. See how this gets verbose very quickly. So aliases is just a way of shortening the code. So we are grabbing from the script data constants from its data enums for object path. So it wants the enum for object path to be used as the data value from the caller object for its object data. The place where it allows us to grab the data value is from the script data manager. So all it's going to do is going to return from the object we passed as the caller object its data value on the key value assigned to it. That's how it's doing. So if we go back here to our action move, we need to grab its path. We check if the path is equal to 0. We return because there's no path. Almost the same thing with our units here. So if path was equal to 0, we set a variable before, and we basically return because there's nothing to move against. That's also what the action move path is doing. Next, we need the variable current path index. It's not a variable inside of the object like it is here. So here we need to cache the current path index, whereas before the current path index was a variable inside of the object itself, as you see here. So our action move is going to check if our current path index is less than the path size. This is to ensure we are only moving to the next path point if we have not reached the end of the path. So next is almost the same code as this one. So we are grabbing the next path point index from the path, just as we are grabbing here. So we want the next path point. We set is y to 0 because we do not want to be floating above ground because of the navigation. Next, we want the direction to the next path, which is the same thing here on our basic units. As you can see here, it's the same line of code. And then we need the move speed, but because now it is not a variable inside of the object, we need to grab from its object data, and we're going to change that our global position. So this is the line that's going to move our object inside of the path. As you can see, it's the same from this one, from our basic units. We're going to look at the path if it's different from the origin. So yeah, the same thing. Now, whenever we want to change a variable inside an object, we need to set the object data. So here on our basic units, if we wanted to change the variable inside of our object, so we have a variable called current path index. In order for us to change it, it's just a matter of calling it and saying it add +1. Now, because we are under a object action, we need to actually set the data value from the object type. So this is doing the same thing as this one. It's setting the current path index to be +1, but because we are setting it on a script that does not know what object we're working with, we need the last path index from the object itself. So we first need to retrieve what the current path index is, next to be adding it +1. In order for us to set that, we need to access its object data through the script data manager. And through the current path index in num of the object color, we want to set its last path index plus 1. So this is doing the same thing, but now under the object data. So we do no longer have that variable instead of the object. We need to set it through the data value, which is going to grab it from, if it's from the same type, we want to set its key to the new value. That is what it's doing here. If the path is higher or plus equal, we want to clear the path. This is where I have actually doing things a little different, because if that is the case, now we have split the function. So this, I think, is the only part where I changed the function. So instead of checking if we have here the distance square, which we also do, I only clear the path size if the path index is higher or equal to the path size. This is the different part of the code. So here, where we will just clear the path, we first need to access the object data for the object, for its object path to be resetted back to an empty array, in order for the follow path function to, whenever check its size on our, let's say, on our path follow, so whenever we check for its size, for it to no longer work, so our unit does no longer move. So that's why you reset the path, and we also reset the path index back to 0. So if you change the path, we need to make sure that we are starting from scratch. That's how it does. Our path function new here is also a little bit different. Whereas before we had access to direct variables from the object, now everything we need to grab it from object data. So for the function here that sets the object path, we no longer have the object path inside of the object. We need to retrieve from the object data to set the new path. New path is generated the same way. We use the navigation server, so that doesn't change. And I also have added this line here of code, which is basically setting the current path index back to 0. So yeah, almost the same thing. And we no longer need this move to path because we are checking for the path size instead. So yeah, that's basically what it does. So the Obj Actions is a transplanted code from our basic unit code to allow it to move. That's almost the same thing. So we can simply select the functions for our new path to use that code instead. So yeah, that's everything it's going to do. So this is everything that Obj Action Move does. It has a bunch of references and stuff, but that is how it does. Now we need the action to allow an object to be selected. So let's build that. So an action to be selectable. And this is actually where reusable components are starting to show their power. And selectable is not actually an action if you think about it, but I have categorized as it is. So let me just paste here the code. So for the action of being selected, we are doing a couple of things. So we are setting the reference here. We are caching our sprite 3D circle sprite selection, not as aliases, but as a resource, so we can use it later. So both actions have an initialize action. We need to set some things up. So in the case of our action selected, we don't want to first have an object selected variable, just as we had here with our selected variable. Then we want to also have the sprite. So before our unit has the sprite here as a node inside of it, we no longer are going to have it. Instead, we're going to add it through the code itself. That is what this code is doing. We are going to be adding that sprite through code and set it above ground here. Next, we want to reference back to the sprite, and we also want to deselect the unit itself, just as the same thing whenever we did startup and set the selected of the unit back to false. So that's the same thing. Next, whenever we select an object, we want to set this internal private method here to false, which is basically going to select or deselect the object, or toggle select, which is going to retrieve the current selection of our variable, and it's going to set it to be different than that. Basically the same thing if we had our object selected. So I believe it was the RTS player. Whenever our selection manager, actually, whenever we toggle an object selection, we simply set it to be selected differently. So that is everything that the toggle selection is doing. It's just setting it different than what it currently is. Next, we want to set the object selection to another value. So first we need to set that selection to the new value. In the case of we want to select it is true or false or different than what it already was. Then next we want to make sure our selection sprite, which is the reference we have stored back on whenever we initialize our objects, as you see here. So we want that reference to be the sprite 3D, and we want to toggle its visibility to true or false. That is everything that this code does. So just by having this on the different one, we are allowed to an object to be selected. And we have these API calls here. So this is everything we need to make the objects have actions. Now, let's apply those actions back to the objects. So let's go to our units. And now, whenever we want to follow a path, and let's actually start here by changing the structure. So first, under our constants, we're going to need a couple of references. We need a reference for the action manager so we can call code from it. So the code that allows us to basically initialize actions is inside of there. We need the constants because we need to reference the constants of the actions themselves. We need also the data manager, which allows us to manipulate object data through the dictionary values and setting their keys. We need the object data constants so we can reference object path, index, goal, selected, everything inside of our unit as we need. And here are the object actions as constants. So I don't think we want an object to perform different actions at different stages. We can do that through different logic. But I want this to be a constant so we have auto-completion. And here you can see that we're going to start using aliases. So aliases is to shorten up code. Otherwise you would need these here. And also, let's say action script is actually this one. So let me show you the length of the code if it was meant to be used without aliases. So this is pretty complicated for you to understand, and technically is correct, but also to type is a big mess. So I have chosen to use aliases, and this is the rule set for aliases. We start with double underlines here. So yeah, this is how I have chosen to format the aliases for things here. So we have aliases to short the code reference to these. So we're basically saying for action scripts, we want the action move to be inside of our object actions. And we also want the action selectable to belong to this object. This object actions is actually almost the same thing from what they do. We now have can move and can be selectable. So that is how it translates back to our object actions here. So that is what the translation looks like. Now we have object actions. So this object can move and this object can be selected. Cool. So now that we have this, we can start working on it. So let's now change our functions here. So whenever we start up, we don't want this. This is the debug information for the ABB. And all I did was to comment that and store inside a separate function. So in that reference project, all I did was just place that inside of a debug function that we can use later if we whenever wants to debug the ABB of this mesh. And we need slight adjustments, but that is what I did. So on our startup of our actions, we want to change this function. We want to now set a object move speed variable, and we want to initialize the actions present in this object actions. So we are calling the actions manager to initialize all the actions we have inside of our variable object actions. Initialize actions is going to, for every single action which is expected as a script, in the actions we pass here as an array, we want to initialize their actions. This is the expected function name that our actions have to have. So our action move has initialize action, and our selectable also have that. This is what the startup function is going to do now whenever our object is ready. That is what it's going to do. Now the code is going to be simplified a lot. So let's remove process. We do not need process. Let's go to the new path function and let's replace all of this code with just a single line. So what is the magic here? We want to access whenever we request a new path from the RTS player, we now need to simply access the action we are using, and it's going to be the action move. and we are going to request a new path from the action, not on the side of this object. So we're not generating the code for the path inside of here, but now instead from the action move new path. That is everything that's doing. And this is the function that's going to return us the path as an object data. So it does not actually return nothing, but it's going to set the object data of our object path with a new path. Almost the same thing that I was doing before, but now through object data. The follow path is just the same thing, but now we do not need it as a separate function because the follow path does not need to be here. Now our physics process needs a follow path function to allow our objects to move. But now we can simply do the following here. We're going to also remove the move to path function, and we're going to simply say that for our object actions, the first action, which is the action of our move object, we're going to call the physics tick function. This is going to simply call the same thing as path follow. So if we have, before we had a variable that said, if we have move to path set to true, we're going to follow the path. Now we are simply check if our path size is higher than 1. Then we know we have a path to move. Then we're going to call path follow, which is going to follow the path just as we did before. Now we no longer need these variables because we no longer need it. In order for the path to be followed, we only need of our object data to have those variables inside as object data, which is pretty cool. Now we have less variables here to work with. So the new path also becomes this fairly simple method here. Now the selected variable we also do not need because the selected action is going to handle all of those things. So in order for us to select an object, we're going to have now public methods that's going to handle those. We're going to access the action of the selection action, which is the second one. So the action that is the selectable action is the second one. So we're going to access that action and call for a select object, which is simply going to call the code inside of that action to an object to be selected, which is going to run that code. So now we have APIs to select, deselect, or toggle select an object. And even these could be inside of another sub-function, but we need to expose this in order for this object to be selected quite explicitly here. So pretty cool. And now we can select an object and we do not need the selectable var anymore. So we can also remove this. Now, in order for us to generate, to follow a path, we also don't need the path function, the variable. So currently we are using it no longer. So we can also remove this one. The movement speed we also are no longer using because we are setting it as an object data variable inside of our object data, and the function that's going to use it is on the action move. Whenever it calls it for a follow path, we are going to grab the object move speed from its object data, as you see here, in order to multiply the move speed of the object. So this does not need to be an exposed variable. So we can also remove that. We do not need the object selection sprite references, neither the ABB. The ABB we need to update the function to add, but the selection sprite we are already managing through the action of an object being selected. We set its variable to be selected to false, add the sprite, and add the reference to the object sprite. So we do not need that reference back here again. So as you can see, we have shortened the code to quite a lot, and now we only have the essence of our action script codes, which is awesome. Now, of course, if we try to run the project with these big changes, I believe we're going to find some errors with the RTS UI interface manager. So let's run it and let's see if everything is able to start. But we already have an issue. We do not have an object data inside of the mesh instance. So that is being called from the startup from the object data enums move speed. So here it seems that we have an issue that we are missing the variable of our object data. So this is the type of error you're going to get. Now you need to be able to read this kind of errors very delicately to understand the first, our system we have put in place with actions and attributes to understand that now we have an error that we do not have a key inside of an object. That key name is object data. So this basically means that our unit does not have the public var of object data. So this is something we need to worry about. Every object in our game needs to have this variable of object data. This is what is going to connect the actions to store and manipulate information from the object, such as we have discussed here. So in order for us to manipulate what they have, it's going to be stored under the object data variable. So now that we have added this should suffice the error, and we are going to be allowed to start. And as you can see, so the actions were able to initialize. Now, when I try to select an object, it's going to fail as well. So what is the error? Invalid assignment of property or key selected with a variable of bool in the object 3D. So basically, inside of our units, we do not have that Boolean type selected. So before we had these variables to be exposed, now we no longer have it. So that is why my solution was to create these functions here. So instead of we having to handle if our objects have or not these properties, our selection manager can simply say that we want this object to now be selected. So this is much simpler, and the internal details is going to be handled by the object themselves. So you can also handle this through another action, but I have decided to simply split this into different functions here to allow it to work. And I believe the last one is toggle select object. Now you need to make sure that all your objects are going to have these functions in order for this to call. So the selection manager, in order to select, deselect, or toggle select objects, need to access the object and access those functions. So now we should be able to select the objects. As you can see, they work. So here we have a couple of systems working behind the scenes. Our action has been able to generate the sprite, is able to set its visibility whenever we select it, and everything is being handled through object data. So if I have this one selected, I escape from that, go to my 3D view, select the object itself. Here we have our object data, and as you can see here, it's unfortunately displayed as integer values. We can see through the script here under our object constants. For the data, we're going to see what they are. This is the same thing as having the object var declared as before. Now it's being handled through the object data, which is awesome. But now the issue with that is if you change the object data, is not going to toggle the visibility, because the code that does this, it's actually through the API of Obj Selectable. Whenever we set the selection, we are switching the variable on and off. And currently, we're only calling this through the toggle select object, which in turn is calling from the units whenever we ask it for to be selected, which in turn is being called from our selection manager whenever we want to select or deselect objects. We're calling those functions. So you're going to see how we have a bunch of functions nested. So it can get complicated very easily if you do not know what you are doing. So yeah, that is the downside of creating structures inside of a project. It's going to get complicated fairly easy. But as you can see, it's working as intended. So as you can see, everything is working now. And we have the actions as they are working as we intended. So now we have done finally an action for move and an action for an object to be selected. Now yeah, this was fairly complex, but as you can see, that is how it works. So now we have started implementing our RTS architecture inside of our objects on our Godot. We have basically transplanted the functions from the basic units to be actions, and we have worked with it. So yeah, that's everything that we have done. So hopefully you were able to follow and understand the code for this project on this part. Hopefully it was not that complicated for you. I'll be storing this as the next project file. You can also download and analyze for yourself if you are currently a YouTube member. But yeah, we'll see what the future holds. So yeah, that's everything I have for you under this part. We are now implemented our unit structure. We do not no longer need the sprites, we do not need anything. We only need now the actions reference. So we say this object has these actions and we initialize them. And whenever that happens, we call a bunch of different code that's going to handle all the magic stuff behind the scenes here through nested sprites on the nested scripts codes. So yeah, that's all I have for you guys today. Hopefully you have enjoyed. And we'll see how we're going to continually build our RTS project inside of Godot. Now with the object structure we have developed here. So thank you guys for watching, and I'll see you on the next part for our RTS project.